Okay, a little technical error here. If you've watched my last four videos, then you know that I'm doing the six released FRQs for AP Stat. And I'm doing them cold. Started the video for number five a few minutes ago, and the video got disconnected, so I had to restart. I'm going to go ahead and work through this, but in this time, I've actually worked through part A already. So I've been trying to do it cold, where I haven't looked at the question at all until I start this video so that you can see the thought process as if you were taking a test. But it didn't work this time. So again, we're doing a problem question number five. You can find it in the link in the description below. You can find the link to the College Board question, so you can open that and follow along while we're working this out in the video. I'm not going to post the question on the video because that's a violation of copyright for College Board, and I don't want to do that. So I do have it open that they released today, and this is, I've already saw part A, but I'm going to go through this again, work with you. So what we have is a survey in country B from 2017 showed the mean number of bedrooms in newly built houses was 2.9. This guy, Rodney, is a researcher, and he believes that in 2024, the mean number of bedrooms is different than it was in 2017. So to investigate this, he took a large random sample of newly built houses in Country B in 2024, recorded the number of bedrooms in each house, gave us a distribution of the number of bedrooms, written as a probability distribution here. It's not what they're calling it. They're calling it a table with the relative frequency of the number of bedrooms in it, but it looks like it's set up like a probability distribution, and that's how we're going to approach this. So we're going to start with this on part A. The house from the sample we selected at random. What's the probability that the house had fewer than three bedrooms? So the range in this distribution is from 1 to 6, and the table has the proportion of houses in the sample with each number of bedrooms. So if we want the probability that selected house has less than three bedrooms, we have to add up the proportions for one bedroom and two bedroom. We're going to write this down. The probability of one bedroom plus the probability of two bedrooms, which equals 0.12 plus 0.22 equals 0.34. That's part A1. Part A2, what's the mean number of bedrooms for the sample of newly built houses in 2024? As I told you, this looks like a probability distribution. We're going to treat it. We're going to let X equal the number of bedrooms in a house in a sample. And to calculate the mean of X, which is the expected value of X, we're going to do the number of bedrooms times its associated probability. Okay, and it's going to take me a second to type that in the calculator. I'm working with a calculator online, so sorry about that. 1 times 0.12 is just 0.12. And 2 times 0.22 is 0.44. So I'm going to add 3 times 0.28. Then I'm going to add 4 times 0.22 is just 0.88. And 5 times 0.14 plus 6 times 0.02 is just 0.12. And that gives us 3.1 bedrooms is the mean. And that's part A. Part B says Rodney will this now we're at the point where I have not looked at the question yet. Rodney will use a one sample t-test for a population mean to test his belief. in the context of Rodney's investigation, state the hypotheses for the test. So we're not asked to do all the justification. They've told us the type of the test. So the hypothesis for the test, we said the mean in 2017 was going to be 2.9. So that's where we're going to start out at. B1, our null hypothesis would be that the population mean equals 2.9. And up here in the question, it says he believes the mean number is different than in 2024. So that means our alternate hypothesis is going to be not equal to 3.1, since that's what he's trying to test. Explain in context what a type 1 error would be for Rodney's hypothesis test. So let's go back to our old table. Let me look at this, make sure you can see this on here. So this is the null hypothesis. It's either true or false. In our conclusion, we're either going to reject or fail to reject. If we fail to reject, or we reject. And so when we reject the null hypothesis, we fail to reject it, we're good. If we reject the null hypothesis, that's a type 1 error. If we fail to reject a false null hypothesis, that's a type 2 error. And if we reject a false null hypothesis, that's a good thing. So we're asked to explain what is a type 1 error. So we would reject a true null hypothesis. So in this case, it says in context, what would that be? In context, this would mean that the true population mean number of bedrooms in country B in newly built houses country B is 2.9 bedrooms, but we conclude the mean is not 2.9 bedrooms. That would be a type 1 error for Rodney's hypothesis test. So part C, let's go ahead and give y'all some more room to see. A different researcher, Keisha, suggests using a confidence interval to investigate whether the mean number of bedrooms in newly built houses in 2024 in country B was different from 2.9. Assume the conditions for inference have been met. We don't have to verify conditions. Using Rodney's data, Keisha calculated a one sample 97% confidence interval to estimate the population mean as the interval 3.01 to 3.19. Based on the confidence interval, what conclusion can be made for Rodney's hypothesis test in part B at alpha equals 0.03? So in this case, the 97% confidence interval in the context of his. So if we were concluding the hypothesis test, let's say that. Because 0 is not in the interval, sorry, because 2.9 is not in the interval, fact, the entire interval lies above 2.9. And the conclusion would be the evidence suggests avoid definitive language. Evidence suggests the true population mean number of bedrooms in newly built houses in country B. Curious about, should I say greater than or should I just say not equal to? Because that was what Rodney's, I'm going to use Rodney's hypothesis and say is different than, because that's the language they use, 2.9. We'll go with that. Could be wrong. I'm interested to see the solutions when they come out. Should I have said greater than because the entire interval is greater than? Or should I have said, let's go ahead and put at the 3% confidence level. Significance level. Okay. This one could cost me points. I'm not sure. I'm interested to see how that comes out in the rubric. So anyway, that's number 5. Number 6 is next. Investigative task.